Hello everybody. Our CMT ID for Texas Instrument Innovation Challenge is 1018 and our project entitled is Microcontroller based Smart Drip Irrigation System. As everybody knows that India is an agricultural country where most of the economy is dependent on agriculture, and the water for agriculture comes through monsoon or tube wells or groundwater. That was the problem because with the passage of time we are running short of water. So we need modern techniques, modern technology to have sustainable development of water. Being electronics and communication engineering student, we have tried to integrate electronics with the recent problem. So here we have made a microcontroller based smart drip irrigation system. First of all, what is the drip irrigation? Drip irrigation involves adding water and agrochemicals to the soil directly and not to the soil profile. It focuses more drop per drop. That's all.
I am Rajat and I am going to tell you about the Tiic components that we have used in our circuit. Firstly, MSP EXP430G2, second LM35CA2 NOPB, third THSI206M, fourth TRP8525PWPR, third LM393DRG. MSP is used for launchpad and it is our brain of our circuit. Second, LM35CA2 is a temperature sensor. THS206M is A to D converter. It converts the analog signal to digital signal. Third, DRP8525 is used for driving the motor. LM393D is for moisture sensor. We have not used the ready-made moisture sensor, so we have used LM393D. Apart from these all components, we have used resistor, capacitor, BJT. And presently our whole circuit is working on breadboard.
Hello everyone. Let me elaborate the description of the component made by my friend through the microcontroller based smart drip irrigation working model. As you can see, this is a launchpad given by the Texas Instrument. This is MSP EXP430G2. It contains MSP EXP430G2 553IC. It is a series of ultra low power mixed signal microcontroller with built-in 16-bit timer. It is 512 MB RAM, 16 MHz frequency, and it has a working range of 1.8 to 3.6 volt, ultra low power consumption. This is the brain of our system. This controls the two sensors connected to it. As you can see, this is a LM35 temperature sensor given by Texas Instrument. This has working range of temperature range of minus 35 degrees Celsius to 120 degrees Celsius. It is a It can use to measure the temperature more accurately than using thermistor. LM35 generates a higher output voltage than thermocouples and may not require that output voltage be amplified. And a scale factor of 0.1 volt per degree Celsius. This analog moisture sensor sensors the moisture contained in the soil. Here you can see we have made a prototype which shows that this is a soil and there is a moisture in the soil. If we add water in this mug, this gives a particular input to this analog moisture sensor. This analog moisture sensor gives this input to the microcontroller. Microcontroller detect this input. If let's say we have made a particular threshold value of 1.6 to 1.8 volt. If this input is greater than this 1.6 to 1.8 volt, this microcontroller sends a high signal, that is digital signal, to this digital to analog converter. Now this digital to analog converter given by the Texas Instrument converts it to a particular analog input and gives this analog input to this amplifier section. Now this amplifier section amplifies this analog input and provides a particular amplified output to the input of this relay section. Now this relay switch activates the motor that is connected to the valve of the emitter of pipeline section that is made in the irrigation. You can see the whole model. That's it. Now I show you the overall working model of our project, that is microcontroller based smart drip irrigation system. As you can see, our prototype of the soil contains no moisture, that is no water. This moisture level is sensed by the moisture sensor, and along with this, that is the innovation of our project. That both sensors are integrated side by side. This LM35 measures the temperature greater than 35 degrees Celsius of the surrounding It is heated but by a soldering rod. When the threshold value given by both the sensors are greater than a particular threshold, that signal is processed by the MSP 430 launchpad and the sensor of microcontroller unit of that. This microcontroller unit gives the particular digital signal to this digital to analog converter IC, and this digital to analog converter IC, as I said earlier, converts the analog input that is given to the amplifier section. Amplifier section amplifies this output and give to relay switch. Relay switch accordingly is driving the motor. As you can see, the motor is being driven. Now my friend will pour water in this prototype, and along with this, moisture sensor will increase. I remove this soldering rod, temperature reduced. Let's wait a minute. As we have seen, as the moisture level increases and also the temperature decreases through a particular value, we have correspondingly stopped the motor that is connected to the valve of the pipeline or to the pump over the irrigation system that is connected through the field. This is a prototype motor. This does not mean that this motor will actually control the valve of the irrigation system. This can be used for driving the pump through which the water can be supplied to the pipeline. That's all. Now I will show you the details of the software components used in the project. We have used Energia platform, that is an open source platform used for debugging program in the microcontroller MSP430G2553. It is an integrated development environment that supports TI's microcontroller embedded processor portfolio. It includes an optimizing C++ compiler, source code editor, project build environment, debugger, profiler, and many other features. Now moving on to the conclusion of this project. This eco-friendly project solves the problem of keeping eye on the irrigation timetable. As microcontroller are used, so only that much water would be provided to the crop as much it's needed. As the water requirement of a crop reaches desired level, the drip system will stop dripping water. As the innovation is so simple that we have used only the temperature and the moisture sensor for controlling the valve of the emitter. We can also integrate it with the Zigbee module or the GSM module that is used for wireless communication. The aim of the project is more crop per drop. At last, I would like to thank the Texas Instrument for giving us this opportunity to participate in such a heavy contest, and thanks for giving us such a innovative components. That's all. Thank you.